Hello class, this is Mrs. Hale speaking. If you would like to follow along with this activity, feel free to go ahead and get a piece of paper and cut it out into a triangle. We did this activity in our physical classroom, so I wanted to go ahead and make a video to share it with you. So first thing we're going to do is start out by labeling our triangle. We're going to go with the generic ABC, and we're going to place those right on our vertices. Now, what we're going to do is we are going to fold vertex C to vertex B, or I guess I should say bend, because we're not going to fold it all the way out. We're just going to pinch right there. And then we're going to do the same for AB. So again, line up the vertices and pinch. Now, what these are here are the midpoints. This point is the midpoint of AB, and this is the midpoint of BC. And I'm going to go ahead and just label them X and Y. So what we're going to do now is we are going to pick up our vertices B and fold it downward right there until our 2 points, we can feel them kind of giving. So we want them to be lined up with those 2 points. And now that it is, I'm going to go ahead and connect them. And now this line segment that we've created here has a lot of special and unique properties, and we are going to use this triangle to discover those today. So the first thing I'm going to do is I'm going to fold that back down, and I'm actually going to take my vertices C and fold it to meet the folded vertices B that I have down here on the baseline. So I'm going to go ahead and do that. And I'm going to go ahead and do the same with A too. And I'm starting to wish that I had not used markers that would bleed through, but we're going to unfold this. And we are going to try to think now about what the relationship between AC and XY is, those two line segments. So since I have folded this in half in here, let me go ahead and mark this dot here on our line. That way you guys can visually still see it. I'm just going to mark it as B apostrophe because it's not really mathematically anything, but I just want you to be able to see it. So basically I folded C to meet B apostrophe, and I folded A to meet B apostrophe. And what we did is we basically found the midpoints between B apostrophe C, so that's there, and A B apostrophe. So these are the midpoints that exist in these separate line segments we have created. So what we've done is we've divided this area in half, and we've divided this area in half. And we can see that this directly lines up with our line segment XY. And what that means is if we subtract congruent, if we subtract half of this and we subtract half of this, and we're looking at AC totally, that means we've gotten rid of 1/2 of AC. And we're left with 1/2 here. And if we follow that up, we see that that goes directly into XY. So we can say now, let me get another marker color. We can say that line segment XY is equal to 1/2 of line segment AC. Let me go ahead and get a pen to draw that in. The flash is just a little bit too bright on that portion. But so this is very important because now we can find missing values for this. And this line segment XY also has a very important name, and that name is the midsegment. And it's called the midsegment because it is made up of the two midpoints of two sides of a triangle. And a midsegment could also exist this way. It would be with this line and this way as well. So you could actually end up, there are 3 midsegments for each triangle. This is just the one we're focusing in relation to AC. So we're going to see if we can find out anything else about this new vocabulary term midsegment we're working with. So what we're going to do is we are going to take our protractor and we are going to line that up with angle A. And if we line it up, we see that we are about 55, a little under 55 for our angle. And obviously this isn't the most accurate measurement because the tick marks don't go that accurate, but we're gonna line this up again. And again, we see we're right below 55. So what that means is we can say that angle A is congruent to angle BXY. And again, I have to use those 3 letters for these angles because if I just said angle X, that could mean this lower angle or that angle. So I have to use 3 letters. But that means that we have congruent angles. And something that we can conclude from having congruent angles is that line AC is parallel with line XY. And that is because of corresponding angles. If corresponding angles exist, we can automatically provide the statement that AC is parallel with XY. And I believe that is in your delta math as well. So let's go ahead and write that out. Again, we're going to do line XY is parallel with line AC. And so these are just some of the properties of a midsegment. We also have that a midsegment will bisect AB, right? Because it has to be at the midpoint. Its endpoints have to be at the midpoint of these 2 sides of the triangle. So we can conclude that. We can also conclude that it bisects, it is a line bisector of BC because again, that line segment endpoint has to be a midpoint. And yeah, and again, these can exist 3 different ways. I don't want to draw those for you now just because I don't want it to get too muddied in the process. But yeah, that's pretty much the essential concept. And these 2 properties are going to be very important for you, especially when it comes to proofs, because knowing that corresponding angles exist is going to be really helpful for proving congruency as well as proving similarity. All right, hope this was helpful, and I hope you guys are having a wonderful day, and I'll see you in class.